Alright, so in the last clip we showed how to create the purchasing power parity forecast, and in this clip I'm going to go through and show you how to make the interest rate parity forecast, and then specifically the equation we're going to use is the percentage change in S equals the uncovered interest parity, percentage change in R minus percentage change in R star, which is the British interest rate. So this is the relation that we're going to use again. That's uncovered interest parity. The expected change in the spot rate equals the interest differential, right? And again, the spot rate's defined as the dollar price at the pound, the UK pound. So we have, this is the US interest rate, and we're going to subtract from that the UK interest rate, and that's what we've done right here in this interest differential. And again, it's already in percentages, so this column, interest differential, is percentages. Remember, this comes from the UK T-bill rate, sorry, the US T-bill rate minus the UK T-bill rate. So what we're going to do now is use that to create an interest, call it uncovered interest parity, UIP, implied. So this is what the uncovered interest parity implies. And we're going to take the previous spot rate and basically scale it up by a factor. What factor? Multiply by what factor? The interest differential here. Right? So I combine this guy right here with this guy through multiplying, and then that's going to give me the next period's exchange rate, a forecast for this period. It's exchange rate, Q2. So let's do that here. Again, what I could do is I have to divide the interest differential here by 100, because this is in percentages. And when we scale it up, scale this exchange rate up, it has to be in a decimal form. So to get this column here in a decimal form, we have to divide by 100. So again, I could create a column, insert, and then just divide this guy by 100. Okay. Or I can just do that. Again, it's shorter. It saves you more time to just do that in this cell right here. So let's do that. Just like the purchasing power parity. We're going to take the previous period spot rate. So that times 1 plus this interest differential divided by 100. You can see the parentheses match up, red with red and then black with black. So this gives me a spot rate forecast. See, from 1982, or sorry, from Q1 of 1982, looking ahead, the spot rate was 1.8461. I'm going to say, what's the forecast for next period, next quarter spot rate? I would say, well, given the interest differential between the UK and the US, the T-bill here, I would predict that it's going to be today's spot rate, or this period's spot rate, scaled up by the interest differential here, and that gives us a forecast. And because I have one formula done already, again, I just drag and drop. And even faster, just double click. I'm going to erase this. So then take the error, just as we did with purchasing power parity, take the uncovered interest parity error, and that's just the actual spot rate minus the forecast, which is 0.06 right here. And then again, because we did one formula, we just do them all. Just double click, thick white cross, black thin cross, double click, and that just fills in the entire column for the errors. Again, we want the errors squared as well. And call this SQ for squared. Adjust the column size, and we're going to do this with formulas. Save ourselves a lot of time. Click the error to raise it to the power 2, gives us this number, and then we're going to double click this, and then we go. What we're going to do to get the root mean squared error Again, that's the statistic that we're using to evaluate these three forecasting models. You take this error squared column, and then what we're going to do is we're going to sum it. So basically take the average of it, and then take the square root of that average. And whichever one is lower of the three will be the better forecasting model. Real quickly, let's do the naive forecast. We'll do another clip, but I think I'll just do it on this one. So the naive forecast, again, technical name is the autoregressive, first order autoregressive forecast. This model just says, this naive forecast just says, you know, what's the spot rate next period? Well, it's the spot rate today. Okay? So you're in 1982, you're in quarter 1, 1982. Someone asks you, what's the spot rate going to be next quarter, 1982? You say, well, it's 1.8461 today. Just assume it's going to be 1.8461 tomorrow, or the next period. So basically, it's sort of like you're assuming that it doesn't change at all. Okay? So what we can do is in the naive column here, is we can lag this one period. How do we do that? I'm going to take this column here, copy, and go over to this column. Instead of pasting here on this first formula, see how it lines up? That would just give me 1.84. I mean, that's not a forecast. I have to click from this first column. I mean, not this first one, but the second column. See, so now, again, this is my forecast. I can delete this. See? In period 2, the actuals, or quarter 2 of 1982, the spot rate was actually 1.7796. My prediction on the naive forecasting, this is what I said in class, the 8th graders' way of forecasting, because it's really, really simple, is 1.8461. Where'd I get that from? Just last period. Right here, 1.8461. I'm going to highlight this, 1.8461. And then what about in quarter 3? Well, it's quarter two's exchange rate. See? Oops, wrong one. Right here. Quarter 2's actual exchange rate becomes quarter 3's forecasted exchange rate. 1.64, go over and down 1.64. Okay. Now take the error of that, so I'm going to call this naive error, and do just like, while I'm up here, I'll do the naive error squared. So what we're going to do is just like the uncovered interest parity error. To take that first column, the spot rate column, the actual exchange rate, multiply or subtract from that the forecasted value. So let's do that. I don't have to click the cell. I can type it in as well. This is B2 or B3. B3 minus Q3. Drag and drop. And then I'm going to take this guy and square it. And then drag and drop. Oop. Then again, to make it look nice, you can center everything. Okay, then the next clip that I'll show how to get the see, we're matching this one, project 2 up here, with this book 1, and we're pretty much done. Naive squared error, naive squared error. So then what we'll do is I'll show in the next clip how to calculate these root mean squared errors. So we'll do that for down here.